Section 11 of Sun, Moon, and Stars, Astronomy for Beginners. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. This is Jade Mansueto, Sun, Moon, and Stars, Astronomy for Beginners by Agnes Giberne. Chapter 1. More about the Solar System. By the word of the Lord were the heavens made, and all the host of them by the breath of his mouth. For he spake, and it was done. He commanded, and it stood fast. Psalm 33, 6-9. We have now reached a point where it ought not to be difficult for us to picture to ourselves with something of vividness the general outlines of the solar system. A while ago this solar system was a very simple matter in the eyes of astronomers. There was the great sun fixed in the center, with 7 planets circling round him. 7, of course, it was said, since 7 was the perfect number, and a few moons keeping pace with some of the planets, and an occasional comet, and a vast amount of black empty space. But astronomers now begin to understand better the wonderful richness of the system as a whole, the immense variety of the bodies contained in it, the perpetual rush and stir and whirl of life in every part. Certainly there is no such thing as dull stagnation throughout the family. First we have the great blazing central sun, not a sun at rest as regards the stars, but practically at rest as regards his own system, of which he is always head and center. Then come the 4 smaller planets, rapidly whirling round him, all journeying in the same direction, and all having their oval pathways lying on nearly the same flat plane in space. Then the broad belt of busy little planetoids. Then the 4 giant planets. Jupiter nearly 5 times as far from our Earth from the Sun, Saturn nearly twice as far as Jupiter, Uranus nearly twice as far as Saturn, Neptune as far from Uranus as Uranus from Saturn, all keeping on a very nearly the same level as the 4 inner planets. In between and about these principal members of the system, with their accompanying moons, we have thousands of comets flashing hither and thither with long radiant trains, and myriads of meteorites, gathered often in dense vast herds or families, but also scattered thickly throughout every part of the system, each tiny ball reflecting the sun's rays with its little glimmer of light. Broad reaches of black and empty space, where are they? Perhaps nowhere. We are very apt in our ignorance to imagine that where we see nothing there must be of necessity be nothing. But for aught we know the whole solar system, not to speak of sky depths lying beyond, may gleam with reflecting bodies great and small, from the great Jupiter down to the fine diamond dust of countless meteorites. In this earth of ours we find no emptiness. Closer and closer examination with the microscope only shows tinier and yet tinier wonders of form and life, each perfect in finish. Not of form only, but of life. How about that matter as regards the solar system? Is our little world the one only spot in God's great universe which teems with life? Are all other worlds mere barren, empty wastes? Surely not at all. So much at least we may safely surmise. Life of one kind or another probably has been, or is, or will be at some future period, upon at all events some of the countless worlds existent in the universe. On the other hand, we must remember that surmise is not certainty, and that we know and can know little or nothing about the matter. The many worlds of the solar system may have been created for some widely different purpose, beyond our present power to fathom or even to imagine. It is not necessary that every world should be formed for one object of supporting life. It may be, as has been suggested by one of the greatest astronomers of our day, that the other planets are but chips struck from the block and flung aside in the making of our world, a world by no means prominent in size or in weight or in radiance, and yet perhaps the greatest in the universe, because of the marvelous development of mind, and because of the extraordinary history of mankind connected with it. The same reasoning may be used for the stars, these millions of suns lying beyond reach of man's unassisted eyes. Are they formed in vain? Do their beams pour uselessly into space, carrying light and warmth and life-giving power to nothing? But here again, how little we know. We stand on the shore of a boundless ocean, able to see but a little way, able to understand not 100th part of what we see. That neither worlds nor suns are objectless or useless may be safely asserted, within certain limits. But what the especial object and use of each bright orb may be, we may not venture to assert. We can hardly venture to even conjecture. I have spoken of the probable fullness of the solar system as a whole. We are so apt to think of things merely as we see them with our short sight that it is well sometimes to try to realize them as they actually are. Picture to yourself the great central sun pouring out in every direction his burning rays of light. A goodly abundance of them fall on our earth, yet the whole amount of light and heat received over the whole surface of this world is only the 2,000th millionth part of the enormous amount which he lavishly pours abroad into space. How much of that whole is wasted? None, though like other divine gifts in nature, light is given with a kingly profusion which knows no bounds. Millions of rays are needed for the lighting and nourishing and warming of our companion planets, while others are caught up by passing comets, and myriads flash upon swift small meteors. Of the rays so used, many pass onward into the vast depths beyond our system, and dwindle down into dim star-like shining till they reach the far-off brother stars of our sun. Have they aught to do there? We cannot tell. We do not know how far the sun's influence reaches. As head and center he reigns only in his own system. As a star among stars, a peer among his equals, he may, for aught we can tell, have other work to do. In an earlier chapter mention was made of the earth's 3 motions, 2 only being explained. First, she spins ceaselessly upon her axis, so does the sun, and so do the planets. Secondly, she travels ceaselessly round and round the sun in her fixed orbit. So does each one of the planets. Thirdly, she journeys ceaselessly onward through space with the sun. So do the rest of the planets. These last 2 movements, thought of together, make the Earth's pathway rather perplexing at first sight. We talk of her orbit being an ellipse or oval, but how can it be an ellipse if she is always advancing in one direction? The truth is the Earth's orbit is and is not an ellipse. As regards her yearly journeys around the sun, roughly speaking, we may call it an ellipse. As regards her movement in space, it certainly is not an ellipse. Think of the solar system with the orbits of all the planets as lying nearly flat, in the manner that hoops might be laid upon a table one within another. The asteroids, comets, and meteorites do not keep to the same level, but their light weight makes the matter of small importance. Having imagined the sun thus in the center of a large table, a small ball with several tiny balls traveling around him on the table at different distances, suppose the sun to rise up slowly upwards, not directly up, but in a sharp slant, the whole body of planets continuing to travel round and at the same time rising steadily with him. By carefully considering this double movement, you will see that the real motion of the Earth, as also of each of the planets, is not a going round on a flat surface to the same point from which she started, but is a corkscrew-like winding round and round upwards through space. Yet as regards the central sun, the shape of the orbit comes very near being an ellipse, if calculated simply by the Earth's distance from him at each point in turn of her pathway through the year. An illustration may help explain this. On the deck of a moving vessel, you see a little boy walking steadily round and round the mast. Now, is that child moving in a circle, or is he not? Yes, he is. No, he is not. He walks in a circle as regards the position of the mast, which remains always in the center of his pathway. But his movement in space is never a circle, since he constantly advances and does not once return to his starting point. You see how the facts are possible side by side. Being carried forward by the ship, with no effort of his own, the forward motion does not interfere with the circling motion. Each is performed independently of the other. It is the same with the Earth and the planets. The sun, by force of his mighty attraction, bears them along wherever he goes, no exertion on their part, so to speak, being needed. That motion does not in the least interfere with their steady circling round the sun. Just as, to use another illustration, the earth, turning on her axis, bears through space a man standing on the equator at the rate of 1,000 miles an hour. But this uniform movement, unfelt by himself, does not prevent his walking backwards or forwards or in circles as much as he will. So also a bird in the air is unconsciously borne along with the atmosphere, yet his freedom to wheel in circles for any length of time is untouched. A few words about the orbits of the planets. I have more than once remarked that these pathways are in shapes not circles but ellipses. A circle is a line drawn in the shape of a ring, every part of which is at exactly the same distance from the center point or focus. But an ellipse, instead of being like a circle perfectly round, is oval in shape, and instead of having only one focus, it has two foci, neither being exactly in the center. Foci is the plural word for focus. If an ellipse is only slightly oval or slightly elliptical, the two foci are near together. The more the oval or eccentric the ellipse, the farther apart are the two foci. You may draw a circle in this manner. Lay a sheet of paper on a board and fix a pin through the paper into the board. Then pass a loop of thread, say an inch or inch and a half in length, round the pin and also round a pencil, which you hold. Trace a line with the pencil, keeping the loop tight, so that the distance of your line from the pin will always be equal, and when it joins, you have a circle. The pin in the center is the focus of the circle. To draw an ellipse, you must fix two pins. Let them be about half an inch apart. Pass a loop over both of them, and again placing a pencil point within the loop, again trace a line carefully all around, keeping the thread drawn tight. This time an oval instead of a circle will appear. By putting the pins nearer together or farther apart, you may vary as you will the shape of the ellipse. In the orbits of the earth and the planets, all of which are ellipses in shape, the sun is not placed in the exact center, but in one of the two foci, the second being empty. So at one time of the year the planet is nearer to the sun than at another time. Our earth is no less than 3 millions of miles nearer in winter than she is in summer, speaking of the winter and summer of the northern hemisphere. 3 millions of miles is so tiny a piece of the 92 millions of miles that it makes little or no difference in our feelings of heat or cold. The orbits of some comets are ellipses too, but ellipses often are so enormously lengthened out that the two foci are almost, if one may so speak, at the two ends of the oval. To draw a good comet orbit, you must fix the two pins on your paper some 5 or 6 inches apart, with a loop of thread just large enough to slip over them both and to allow the pencil to pass round them. When your ellipse is drawn, you must picture the sun in the place of one of the pins, and you will see how in their pathways the comets at one time pass very near the sun, and at another time travel very far away from him. It is generally found in families not only that the parent or head of the family has great influence over all the members, but that each member has influence over each other member. Brother influences brother, and sister influences sister. This too we find in the solar system. Not only does the sun by his powerful attraction bind the whole family together, but each member of the family attracts each other member. True, the force of the sun's attraction is overpowering in amount compared with others. The sun attracts the planets, and the planets attract the sun, but their feeble pulling is quite lost in the display of his tremendous strength. Among themselves we see the power more plainly. The earth attracts the moon, keeping her in constant close attendance, and the moon attracts the earth, causing a slight movement on her part, and also causing the tides of the sea. Each planet has more or less power to hinder or help forward his nearest brother planet. For instance, when Jupiter on his orbit draws near the slower Saturn on his orbit, Saturn's attraction pulls him on and makes him move faster than usual. But as soon as he gets ahead of Saturn, then the same attraction pulls him back and makes him go more slowly than usual. Jupiter has the same influence over Saturn, and so also have Saturn and Uranus over one another, or Uranus and Neptune. In early days, astronomers were often greatly puzzled by these quickened and slackened movements, which could not be explained. Now the perturbations of the planets, as they are called, are understood and allowed for in all calculations. It is indeed by means of this very attraction that the planets have actually been weighed, somewhat in the same manner, to illustrate it roughly, as one might test the weight of two strong children by setting each to pull against the other and seeing which could pull the hardest. What a wonderful difference we find in this picture of the solar system, as we now know it to be from the old world notion of our Earth as the center of the universe. When we think of all the planets and of the magnificent sun, when we pass onward in imagination through space and find our sun himself merely one twinkling star amid the myriads of twinkling stars scattered broadcast through the heavens, while planets and comets have sunk to nothing in the far distance, then indeed we begin to realize the unutterable might of God's power. Why, our earth and all that it contains may be regarded as but one grain of dust in the wide universe. And yet, is there great and is there little intrinsically? We do not know. Probably not, as we see either. The might of God is no less shown in the exquisite finish of a flower or an insect than in the fiercest radiance of the stars. And little though our earth may be, it was not too small or too unimportant for the kingly Creator himself to dwell here for over 30 years, and here to redeem with his life the life of man. For not even in one corner of his boundless universe might evil be left to reign unconquered. End of section 11.